grade 10. How are you today? I hope you are fine, healthy, and safe. I am Teacher Mona Lisa. Welcome to another lesson of Mathematics grade 10. Today, you will learn about geometric sequence. Specifically, you will define, determine, and illustrate geometric sequence and differentiate geometric sequence from arithmetic sequence. First, let us ponder these questions. Have you ever wondered how plants grow? In your Facebook account, how would you know how many likers or reactors will you have in a couple of minutes if a certain pattern is observed? When saving your money in the bank, have you realized how much will it increase monthly, quarterly, or yearly? These are just but situations that will help you arrange or organize things accurately and make wise decisions. Consider yourself depositing an amount of money in a local bank which offers 8% interest rate compounded annually. If you deposited 10,000 pesos in the bank, how much money will you earn after a year, 2 years, or 3 years? Let us compute for the simple interest which is only paid on the initial principal amount. Principal amount plus interest earned equals end of the year balance. So 10,000 pesos plus 10,000 pesos multiplied by 0.08 equals 10,800 pesos. How much will you earn in 2 years? 10,000 pesos times 1.08 times 1.08 equals 11,664 pesos. How much will you earn in 3 years? We have 10,000 pesos times 1.08 times 1.08 times 1.08, and that is equal to 12,597.12 pesos. From the given situation, the principal amount you have is 10,000 pesos. Then after a year of investing, you had a remaining balance of 10,800 pesos. After the second year, you obtained a remaining balance of 11,664 pesos. And 12,597.12 pesos after the third year. That shows the remaining balance you obtained for 3 years. The first term, A sub 1, which is the principal amount, is 10,000 pesos. The second term, which is A sub 2, obtained by multiplying 10,000 pesos by 1.08 is 10,800 pesos. And the third term, which is A sub 3, is obtained by multiplying 10,800 pesos by 1.08, and we have 11,664. And the fourth term, A sub 4, obtained by multiplying 11,664 by 1.08 is 12,597.12 pesos. From that, you can predict the next. Consider the principal amount as the first term. The second term will be the remaining balance after a year. Then the third term will be the remaining balance after 2 years, and so on. The terms were obtained by multiplying a constant value, which is 1.08, from the preceding term. The constant value is referred to as the common ratio R, and the terms can be denoted by A sub n where N refers to the replacement of the term. This sequence is an example of geometric sequence. How will you obtain the common ratio? The common ratio is obtained by a sub 2 over a sub 1, or a sub 3 over a sub 2, or a sub 4 over a sub 3, and so on, up to the succeeding term over the preceding term. Therefore, the fifth term of the sequence can be obtained by fourth term times the common ratio equals the fifth term. A sub 4 times R equals a sub 5. So we have 12,597.12 pesos times 1.08, and that is our a sub 5. Therefore, a sub 5 is equal to 13,604.76 pesos. Let's have this activity. Find the next three terms of the geometric sequence 3, 21, 147, and so on. To find the next three terms of the sequence, first, identify the common ratio R. R equals a sub 2 over a sub 1 equals 21 over 3, which is equal to 7. Afterwards, multiply the obtained common ratio R to the preceding term to get the next term. A sub 1 equals 3. A sub 2 equals 3 times 7, which is equal to 21. A sub 3 equals 21 times 7 equals 147. A sub 4 equals 147 times 7, which is equal to 1029. A sub 5 is equal to 1029 times 7, which is equal to 7,203. And the last, a sub 6, which is 7,203 times 7, is equal to 50,421. Therefore, the next three terms of the geometric sequence are 1,029, 7,203, and 50,421. Let's have the second activity. You are planning to buy a new blouse which costs 300 pesos as a present to your mother this Christmas season. You started saving money on the first week of November and doubled the amount to be saved every week. If you started saving 5 pesos on the first week, will you be able to buy the blouse at the end of the second week of December? What is the sequence obtained? To solve the problem, you must have to analyze accurately the given situation. The amount to be saved is doubled every week. Therefore, we must multiply the preceding terms by 2 in order to obtain the succeeding terms. The initial amount saved is 5 pesos, while your target amount at the end of the second week of December is 300 pesos. To represent the situation, we have 5 pesos, which is the initial amount saved in the first week of November. 300 pesos, target total savings at the end of the second week of December. There are 6 weeks from the first week of November up to the second week of December. On the first week of saving, the weekly savings is 5 pesos. And the second week, 5 pesos times 2, which is 10 pesos. And the third week, we have 10 pesos times 2, we have 20 pesos. On the 4th week, 20 pesos times 2, so the weekly savings is 40 pesos. On the 5th week of saving, we have 40,000 pesos times 2, therefore, the weekly savings is 80 pesos. And the last, on the 6th week, we have 80 pesos times 2, which is equal to 160 pesos. So, the total savings for the 6-week duration is 315 pesos. Adding all your savings from the 1st week up to the 6th week will enable you to identify if it's possible for you to buy the blouse for your mother. From the table, the amount obtained is 315 pesos. Therefore, you will be able to buy the blouse at the end of 2nd week of December. The geometric sequence obtained is 5, 10, 20, 40, 80, 160, and so on. Now, it's your turn to answer. A frog jumped 20 centimeters away from a door and then jumps again 15 centimeters away from the 20 centimeter point. The frog reaches 3/4 of its preceding distance each time it jumps. So, we have the number of jumps and the distance covered. So, what is the distance covered on the first jump, on the second, and on the third? If your answer is 20, 15, 45/4 respectively, then you are right. Now, let's have another discussion. Given the sets of geometric sequence, identify the value of the missing term that will satisfy the given geometric sequences. Number 1, 3, 12, 48. So what's the 4th term? Second. First term, 32, 64, 128. So what's the first term? For number 1, we have 3, 12, 48. Then what's next? The missing term is a succeeding term and comes after 48. The common ratio is 4. 12/3 or 48/12. To obtain the missing term, multiply 48 to 4. Therefore, the missing term in the geometric sequence is 192. On the second problem, first term, 32, 64, 128. The missing term is a preceding term and comes before 32. The common ratio is 2. To obtain the missing term, divide 32 by 2. Therefore, the missing term in the geometric sequence is 16. Let us remember to identify the missing term. First, we must have to find the common ratio. If the unknown value is a succeeding term, then multiply the preceding term to the common ratio. If the unknown value is the preceding term, then divide the succeeding term by the common ratio. Now, it's your turn to answer. Identify the value of the missing term in the geometric sequence. Number 1, blank, 32, 16, 8. So what is the first term? If your answer is 64, then your answer is correct. Now, what about the geometric sequence 100, 50, 25, and blank? What's on the blank? If your answer is 25 over 2, then you are correct. Now, let us try to differentiate arithmetic sequence from geometric sequence. Let's have two sequences. Number 1, we have 5, 12, 19, 26, 33, and so on. Second, we have 3, 12, 48, 192, and so on. What can you say about the pattern that is being followed by the terms or numbers in each sequence? What pattern do you observe in sequence 1? How about in sequence 2? In the first sequence, 5, 12, 19, 26, 33, the first term denoted by a sub 1 is 5. It is followed by the second term, a sub 2, which is 12. Then the third term, a sub 3, which is 19. The fourth term, a sub 4, 26, and so on. You can observe that in order to obtain the second term, you add 7 to the first term. And to obtain the third term, you add 7 to the second term. So the pattern is 7 is being added to the preceding terms to obtain the next terms. The number that is being added to the preceding term to get the next term is referred to as the common difference D of an arithmetic sequence. So in the sequence, 5 plus 7 equals 12, plus 7 equals 19, plus 7 equals 26, plus 7 equals 33, and so on. So the common difference D is 7. The common difference is obtained by a sub 2 minus a sub 1, or a sub 3 minus a sub 2, or a sub 4 minus a sub 3, and so on. Generally, to get the common difference D, we have succeeding term minus preceding term. Remember, an arithmetic sequence is a sequence obtained by adding a common difference D to the preceding terms in order to obtain the next terms. In the second sequence, 3, 12, 48, 192, and so on, 3 is the first term, 12 is the second term, 48 is the third term, and so on. The first term, a sub 1, is multiplied by 4 to get the second term, a sub 2. The third term, a sub 3, is obtained by multiplying 4 to a sub 2, and a sub 3 is multiplied to 4 to get a sub 4. So, the pattern is 4 is being multiplied to the preceding terms to obtain the next terms. The number that is being multiplied to the preceding term to get the succeeding term is called the common ratio of a geometric sequence. The common ratio is obtained by a sub 2 over a sub 1, or a sub 3 over a sub 2, or a sub 4 over a sub 3, and so on. So, in general, the common ratio is succeeding term over preceding term. Remember, A geometric sequence is a sequence obtained by multiplying a common ratio to the preceding terms in order to obtain the succeeding terms. Let's have more examples. Determine whether the sequence is geometric or arithmetic. First, we have 12, 15, 18, 21, and so on. First, let's investigate if a common ratio or a common difference exists. Using the first three terms, 12, 15, and 18, we have a sub 2 over a sub 1, which is equal to 15 over 12, which is also equal to 5 over 4. And a sub 3 over a sub 2 is equal to 18 over 15, equal to 6 over 5, but 5 over 4 is not equal to 6 over 5. We got the ratios of two pairs of consecutive terms, but we failed to obtain a common ratio. So the sequence is not a geometric sequence. Now, let's try to obtain a common difference by using the first three terms, 12, 15, and 18. A sub 2 minus a sub 1 is equal to 15 minus 12, which is equal to 3. And a sub 3 minus a sub 2 is equal to 18 minus 15, which is also equal to 3. And 3 is equal to 3. We perform subtraction in two pairs of consecutive terms, and we were able to obtain the common difference 3. Therefore, we can conclude that the sequence is an arithmetic sequence. Let's have the second sequence: 5, 15, 45, 135, and so on. Now, let us see if there is a common ratio. A sub 2 over a sub 1 is equal to 15 over 5, which is 3. And a sub 3 over a sub 2 is equal to 45 over 15, which is also equal to 3. There is a common ratio of 3. Therefore, the sequence is geometric. Now, it's your turn to answer. Determine if the sequence is arithmetic or geometric. We have 1, 3, 5, 7, and so on. If your answer is arithmetic sequence, then you are correct. Now, what about the sequence 40, 20, 10, 5, and so on? Is it arithmetic or geometric sequence? If your answer is geometric sequence, then you are right. Before we end, let us summarize what we have learned today. First, a geometric sequence is a sequence obtained by multiplying a common ratio to the preceding terms in order to obtain the succeeding terms. The common ratio is obtained by a sub 2 over a sub 1, or a sub 3 over a sub 2, or a sub 4 over a sub 3, and so on. So in general, the common ratio is equal to the succeeding term over the preceding term. That's all for today, my dear learners. I hope you learned a lot from today's session. See you on our next episode. Always remember, stay safe and enjoy learning mathematics. Again, this is Teacher Mona Lisa. Have a good day and keep safe, everyone.